All right. Welcome back, everybody. So today we are going to be diving into Django model validators and serializers. We're going to be covering essential concepts that will help you build a more robust and secure Django-based API. And what we're trying to make sure the API is built with integrity, consistency, and security at its core. All right, we're going to be learning about the model field validators. We're going to be talking about the serializers and even diving into some testing to test out our validators and serializers to see how they work. And also, this will kind of give you a better idea when you're working your assignments as well. That way, our applications can handle our data a little bit more efficiently without getting some errors. We're going to be talking about the validators and testing and constructing our serializers. So, Django ORM validators. So the step for creating a model, we kind of started that yesterday. We saw how that works, right? We created a class that inherited from the models.model class that belongs from Django. We essentially need to be able to create some form of validation fields. And these are kind of like constraints to a certain extent, right? We saw that a little bit with PostgreSQL whenever we created a check to ensure that the value that was inputted within a field match a certain criteria, whether it was like less than or greater than a certain value. After creating the validators, we should be able to make migrations, right? We create a log, what our models have that Django can use. It uses those to create our models, which we then migrate into our database. And the final step of the model creation is actually testing out our models. So we've gone over how to create a model. We went over the basics of the fields, the different types of fields. We talked about some, specific attributes like unique, null, blank, and so on and so forth. And today we're going to be talking a little bit more about the validators and what they provide for us. All right, we haven't really touched too much on it. You saw a small sneak peek, but I believe after today's class, you'll have a better understanding of what that's going to look like. So right now in my VS Code, I'm currently within the validators and serializers assignment for today. I left this purposely blank, and we are going to do a small, quick 10-minute review to build our project so we can add our validators in here. Hopefully this kind of gets you into Django mode and kind of refreshes your memory on everything that we covered yesterday. Who can talk me through the first part of starting our project? What do we want to do before we even begin?
Install Django.
We're going to want to go into a virtual environment.
Yeah,
Correct, Gary. We want to go into a virtual environment. Good job. Good guess, Jacob. We want to create a virtual environment. As you guys recall yesterday, we want to create some kind of a container where we can install the different dependencies that our project is going to require. So to create a virtual environment, what command do we use?
Source, the name of your environment.
All right. Let me get one. Buyers.
Source and the path to your environment with bin / activate.
On the right track. Source is going to be what we use to activate it, but to create our virtual environment, we're going to use the Python-M for module. And the module we are going to use is going to be venv. And I am going to create a virtual environment in my environments directory. And I'm going to call this pokeenv. And then we are going to run this. And if I do ls and check what my env is, I see that I created my virtual environment within the directory where I have all my environments consolidated. Now to activate it, going back to what James Byer said, we're going to use source. I'm going to call the environment I want to activate, which is pokeenv, bin, and activate. And we're going to notice here that my environment is now created. As mentioned before, I'm currently within the directory for validators and serializers. I'm going to create a directory here where I'm going to store my demo project that we're going to be covering throughout today's class. I'm going to go ahead and come into this directory. And then what is the next step of actually creating my project?
We're gonna install Django.
We're going to install Django. And what command is that?
Pip install Django.
Pip install Django. All right, we're going to come down to our terminal and we are going to say pip install Django. We see Django gets installed. And now what is the next step? What else do we want to ensure is updated?
Pip.
Yeah, pip install, and I want to say upgrade pip, I believe. We see here it's up to date.
Is there any reason why we don't do the upgrade of pip before we install Django?
Normally, yes. We do want to ensure pip is installed before Django. In the curriculum, it actually has Django and then pip, but that is a good question. Pip is normally ensured it's updated before we actually start using it to install Django. Thank you for that question, Virus. All right, so we install Django. We have pip updated. What's the next step? Well, we just added some stuff in here. We probably want to ensure that we have a project, right? So the command for creating our project, as we discussed yesterday, was by using Python dash M. I'm sorry, correction. It was dash M. Django start project, and then I'm gonna call this my Pokédex project, and then I'm gonna use the dot to create a nested directory. And we see here that my Pokédex project was created successfully. We have dependencies within our project. What do we want to do with these dependencies?
Put them in our requirements.txt.
Yeah, we want to put them in the
file.
requirements.txt. And why do we want to do that, Owen?
That way, when you go to launch this project, that the user can then download the requirements on their own without putting all those requirements on your repository.
Yeah, that's a good point. We're not going to add a virtual environment within our version control. So we probably want to have some form of record of what dependencies project is relying on. And by doing this, we create a text file that has the current installed dependencies in my project. So I have my project started. I got my requirements. The next step is going to be creating a application, right? We're going to be working with the same thing we did yesterday. So we want to create a Pokemon app. And how do we create a Pokemon app?
You can either go into the same directory as your Pokédex _ project, and then you can run the Python manage.py start app, and then your app name.
Correct. We're going to be in the same directory wherever my manage.py file is. Right, this is kind of like the main script that's going to help us run these different commands that come with Django. So we run Python manage.py. We're going to start app, and I'm going to start a Pokemon app. I'm going to run this. We see here that my Pokemon app was successfully installed. So we have my project and we have my app. what is the next step? We probably want to create a database, correct?
Correct. Can you zoom in 2 clicks when you get a chance?
Absolutely. I'll do one because I feel like two is a little excessive. So we'll do one. Hopefully this is okay. We want to create that database. I have one from yesterday, so I'm going to go ahead and just drop it. So drop db pokédex.db. It drops it, and then I'm going to recreate that Pokédex DB. And I can open up a different terminal just to ensure that it was successfully completed. We'll say PSQL Pokédex DB /D. Our Pokédex DB is created. There's currently no relations, letting me know that this is a brand new Pokédex database. It doesn't have everything that I had yesterday on it. So we have our Pokemon project, our Pokemon app, and we even have our database. What is the next step for everything to work within my project? Yes, Gary.
I gotta go to the settings.py.
Yeah, we're going to go to our settings.py and ensure that our Pokemon project is actually tracking everything that we have within our project. We're going to want to add our applications. So we go to the installed apps and we're going to add our Pokemon app that we've created. Who can remind me what the rest of these applications are? You don't have to tell me what the applications really do, but what is all this stuff? Okay. Quietness, and I see Gary say he forgot. Thank you for the honesty. These are some default apps that come with Django. That one of the reasons why we use Django. We have the admin application, which allows us to use like the admin site. We have authorization, which allows us to create like user authentication, and so on and so forth. These are just defaults that come with Django and are necessary for us to use Django. And when we migrate, you'll see a bunch of additional migrations happen, and those migrations are coming from these installed apps. So our Pokemon or Pokédex project is currently talking with our Pokemon app. What is the next thing that we have to configure in our settings.py?
Your database.
Our database, right? So we have a section here for databases. We have the engine and the name. We want to remove the default SQLite that they have here, and we're going to add the database we're using, which is PostgreSQL. And what is the next step for actually connecting my database?
Gonna change the name to the actual name of the database.
Correct. We're going to want to change the name of our database to match the database that we have created. And this database is called Pokédex DB. Now, our database is connected, but at this moment, can Django efficiently talk to our database? Yes or no?
You need to cycle PG. You need to install to be able to do that for them to
Correct.
communicate to each other.
At this moment, Django doesn't know how to communicate with our database. And to do that, we have to install an adapter. And that's going to be our cycle PG. Why is it not scrolling? There we go. Our cycle PG binary, which gives it some form of like almost like an interpreter between Django and PostgreSQL so they can communicate. So we're going to say pip install and we cycle PG. I think I spelled that correctly. I don't know if it has an H in it. Cycle PG. And then we're going to say binary. Thank you, Gary, for the command. And we see here that we install our adapter, right? Now we have a new dependency. What should we do when we install a new dependency?
Update the requirements.txt.
Correct. We want to update our requirements .txt file. So we're going to say pip freeze. I want to freeze it into requirements.txt. And we can see our requirements.txt has been updated successfully with our CyclePG binary dependency. So up to this point, we created a new project. We have the virtual environment with the dependencies that our project is relying on. We have a Pokemon app. The app is talking to our project. We created a database. We have CyclePG, so our database and Django can speak to each other, and we connected our database to the project itself. Now we can actually start working with our project. We completed the setup. So we're gonna go to our Pokemon app, and we are going to create some models. Let's move this to the side. All right. Give me a second here. So we are within our models, and we are going to create our class of Pokemon. So we say class, gonna be Pokemon, and what do we want to inherit from?
Models.model with the capital.
Correct. We want to inherit from models.model, so we can take advantage of the models class that comes from Django. And then we want to actually create our fields in our Pokemon. So we're going to create the name for last week. This was models.char field. And the name is going to have a max length of 200. We're going to say blank is equal to false to ensure that we take input. And then we will also say no is equal to false. We also had a level, which was of type integer field. And the default for this was 1. We had a date encountered of type date field. And the default for this was 2015-01-1. And then we have date captured, I believe. The date captured. Actually, I don't think we added the date captured. I think we only had date in group. Whenever we catch Pokemon, if you guys are savvy with Pokemon, you catch Pokemon, you can actually check your your PC in Pokemon and see when you captured a Pokemon. I mean, so I heard. I don't know about Pokemon. That's that's below me, right? But models dot date time field, right? And then for this date time field, we're going to use a module that comes with Django. You guys probably saw this on the examples, which is why I'm bringing it up. And we're going to say from Django.utils. This is part of Django and its utilities. We want to import time zone. And in the default, I'm going to say time zone dot now. And you can take a wild guess at what date capture is going to have whenever I instantiate a Pokemon.
Just the current date.
Yeah, it's going to have a date and a time of when this Pokemon instance was created. So if I were to create an object right now of Pokemon, the date will say November 14th, 2024, time 9:20 a.m. Right? The time zone dot now, it takes the current time of your location and it saves it to that. Next, we're going to say description. And this description is going to be a text field. If you guys know anything about Pokemon, the Pokédex is able to scan a Pokemon and tell you a small description of what that Pokemon is. Our default is going to be unknown, right? If you've never seen that Pokemon or it's one of those rare types, ancient Pokemons, you probably won't know anything about that Pokemon, so it'll say unknown. And then we want one more field, which is going to be whether something is captured or not. We're going to say models.boolean, and the default for this will be false. Right? We now created our model. What is the next step after our model has been created?
Make migrations.
Good stuff. I saw Gary raise your hand, but Juan beat you to it. We're gonna want to make migrations. We're gonna use our mags.py tool again. Mags.py, make migrations. You can see here that the migrations was created. We created that model, and the migrations folder has been updated. We essentially created like a snapshot of what our models looks like, added that log to the migrations folder, but is our current database tracking this? It is not, right? We essentially just create that snapshot, but we haven't added anything to our database. And to do that, we want to use the migrate command. And we see here that all the migrations were created successfully, and my database should now be tracking the default tables that come with Django, as well as the ones that we created, which is Pokemon at Pokemon and the ID sequence. Awesome. Now, validators. Let's talk about validators, right? So what validators allow us to do is add some additional constraints to our fields, right? And essentially, if we check out what validators are, we can come to the documentation and let's look for validators. Right? You can use documentation to find out what validators are, and essentially validators is a callable, right? Essentially it's a function, right? Something that's callable is a function, and this function takes in a value and raises a validation error. And this should be somewhat familiar for those of you that went through FOP or have created custom made errors, but it's essentially a function that can check the constraints of a field, and depending if it meets those constraints, can either pass or raise some form of validation error to let you know that it did not meet that criteria, right? And those are going to be very useful to ensure that we get the data that we want for our field types. We see a small description here where we are trying to validate if a value is even. They take that value and they go to check. If it does not equal 0 using the modulus 2, then that means that the value they added did not meet the criteria of it being even, therefore it raises that validation error. And it's kind of what we're trying to do here. We do have a bunch of built-in validators that come with Django. We have regex validator, emo validators, we have URL validators, and so on and so forth. And you guys are more than welcome. I encourage to kind of go through here to see what we can use. The first one we're going to use today, some simple ones are going to be stuff like min value, max value, that we can use on stuff like level. So going back to our model, we have some default validators that come with Django, and we're going to see how we can use that. Well, to use the validators, you're going to come to the top of your model, and you are going to import your validators. And these validators come from Django.core. So you say from Django.core, import validators. Now, every time you add a new validator, you kind of have to spell out validators and then add the validator you want to add. So to not constantly spell out validators, we're going to give this an alias. So we'll say as v. So we don't have to continuously just type it out. And now we have access to the validators. Now to use them, when it comes to the field that we want to use them in, I'm going to add it to level. And you're going to call out validators. Because if you recall, validators is a function that's callable, right? Within here, you're going to open and close brackets. We are using v, right? Because that's the alias that we gave our validator. And then the one we're going to use is min value validator. And the minimum I want for my level is 1, right? It should not be anything less than 1. We're trying to stick to the rules of Pokemon here, right? And then we're going to add a different validator, which is going to be the max value validator. And the max value for our Pokemon should be 100. That's going to be the cap for our Pokemon. Do I have any questions about what validators are, how to import them, or how to use them in our field?
Will you always use it within the attributes field right here?
Yes.
Or what if it's a longer one?
You will use it within here, right? You have to call the validators and assign it something. You open and close the brackets. Even if it's just one, you still have to do it within the brackets.
All right. Thank you.
No problem. Let's use these in a different field. We're going to come to the description. And I'm going to say, once again, validators is equal to open and close brackets. And I'm going to say v dot, instead of the min value, I'm going to say min length. Why is it not liking this? Oh, okay. I see you. I didn't add a comma here. There we go. We're going to add the validators. We give it the minimum length. And the minimum length I want for this is going to be, let's look at this. 1, 2, 3, 4, 5, 6, 7. So 7 characters. And then I'm going to give it a max value. So I'll say v dot max. I'm sorry, I misspoke. I didn't need to say value. I'm going to say max length, right? Because this is a text field, right? If you try to add a value to it, you're going to get an error because it's text, not in a type integer like level was. And the max length is going to be 150 characters long. Do I have any questions? Yes, James.
Do the validators that you make have to match, or I guess the other way around, does the default that you have in there have to fall within the validator parameters you're setting?
That is a good question. And thank you for asking that. Let's see how that works. Let's actually change this. Instead of 7, I'm going to add 10. We'll keep it to that so we can actually run into this later. But essentially, it does. And you're going to see how that works. Any other question besides James? All right. If I have no further questions, I'm going to go ahead and open up a different terminal here. And I'm going to use my shell within here. And how do we open up our Django shell? Yes, Demi. How do we do this? You got to install the mic.
Gonna be Python,
Using
yeah.
it's a shell command.
Yeah. So how do I
Yeah,
type that out?
Python, was it Python something manage.p and then shell?
Yeah, manage.py. We want to call our manage.py tool and then shell, right? No such file, and that's because I am currently not within my
Directory.
demo.
Yeah.
And I also don't have my virtual environment open within here. So I'm going to say source, envs, pokey env, bin activate. All right, so we say Python manage.py shell. And can you guys remind me of what we have to do when we open up a shell to use the different types of models or what we have?
Oh, I don't see the comments going crazy now.
I believe it was
Everybody
import
real
from alpha.
quiet. I got y'all into shell.
I heard you, Juan. You are absolutely correct. We have to import our models, right? The shell doesn't understand or it doesn't talk to this. It doesn't know what we have. So we essentially have to import from Pokemon app dot models, import the model that we want to use. And as a matter of fact, before I move forward, what did I fail to do, guys?
Make your
Semicolon.
Migrate.
Make your
Migrate.
migrations.
Thank you. Make my migrations. And that's very important, right? I saw a lot of issues yesterday with like stuff not working, and that's because we edit our fields and we fail to migrate as we should. So let me go and exit out real quick. I'm gonna go back within here and I'm gonna say Python manage.py, make migrations. You see here that I did alter my fields and now it is tracking it within my migrations, but my database doesn't know about this change, so I have to migrate. Good stuff, good catch, guys. All right, now we can successfully go back to our shell and once again say from Pokemon app.models, import Pokemon. All right. Now, let's see what I have in my database. I'm going to say all Pokemon is equal to Pokemon.objects.all. And then let's print out all Pokemon. And I don't have anything in here, right? I dropped the database. I recreated a new project. I don't have what I have yesterday. So I'm going to want to create some new Pokemon. I'm going to say Pikachu is equal to Pokemon. I'm going to call the model. The name is going to be Pikachu. And the level is going to be 102. Right? And right off the bat, we already know that we just created some validators that are supposed to identify if this is going to. Well, to actually test our validators, we have to use a specific command within our shell. And that command is called full clean. Right? But what is the full clean? If we come to our documentation, we can look for full clean. Where is it at? I see it here, but I'm looking for something specific. This wasn't the documentation I was looking for. Go back to validators. How validators are run. Where is it at? I should have prepared better ahead of time. Okay, well, I will save that for later and show you documentation later. But essentially, what full clean does, and full clean isn't the only type of clean method there is for validators. There are different clean methods that do different things. I believe there's 4 in total, and each clean method does something different. Depending on the type of clean method that you run, one can test whether something is null or blank. Another one would check a unique constraint. A different type of clean method will actually check your validators that you created. And what the full clean method does, it combines all these other clean methods that you have access to, but it runs all of them at the exact same time. Hence the name full clean, right? Now, we teach full clean because, what's the point of trying to run everyone individually if you have one that just checks everything? So by running full clean, we are going to see is that I get back an error. And notice it here that the error is a validation error, and it says level and it says ensure this value is less than or equal to 100, right? And even gives me a description of what that error is, right? It has 7. So the validator that I added to my level actually worked. Well, unfortunately, if I do Pikachu.save, notice I don't get an error. And if I select all from Pokemon app _ Pokemon, you see that it was added to my database. And why does it do that? That sounds kind of like, contradictory, right? Well, the reason it does that is because Django wants to give us as much control as possible as developers. That even though it goes against the validator constraint, if I want to put something in my database, I'm going to. And that's what it's trying to do. It's trying to give us the power, like, hey, if you want to do it, go ahead and do it. But it still gives us the tool like full clean to ensure that we can test our validators. All right. So let's go back to our shell. Let me just go ahead and do Pikachu.level is equal to 100. Pikachu.full clean. And it's not working because it's still tracking the previous change. Full clean.
I think it's also encountering the description
It's
error.
encountering the description error. Thank you, Tristan. You beat me to it. It's encountering that error, right? So going to the question that James asked, does our default like still work against our validators? Yes, it does, right? Even though we created, we added a default of unknown, it's going to give us an error because it doesn't meet our criteria, right? So essentially what I would have to do is I would, for one, to not get this error again, is probably change my validator or change my default. For this moment right now, I'm just gonna say Pikachu.description is equal to unknown Pokemon. And then let's run full clean again. I no longer get any error within my Pikachu. That means it's good to save. I say Pikachu.save. Now let's check out what Pikachu is. I haven't added a dunder method, so I won't be able to see it. I can see the description, and I can see the level being 100. But the important part here is that it was able to pass my full clean method. Do I have any questions on actually testing out my validator? Yes, Gary.
Can you go over how you went past the validator again?
Yeah,
Like
so
how you bypassed it?
okay, yeah, of course. So let's create another Pokemon. I'm gonna call this Charizard, and I'm gonna say Pokemon name is equal to Charizard, and level is equal to 10. Or once again, we'll say 102. Right? When we call Charizard and we run the full clean method, it's going to give me an error because obviously it doesn't meet the criteria in 2 different areas. We see the level and we even see the description, right? Being that unknown is a default, which is 7 characters, but our validator says that it's supposed to be 10. Well, the full clean method will test your validators, but the shell still gives us the power to save our Pokemon, even though it doesn't meet the criteria. So even if we do Charizard.save, it's going to ignore the fact that the validators do not match and still add it to our database, right? And once again, to reiterate, why does it do that? It sounds contradictory. Well, it's because Django is trying to give you the power as a developer to still create what you want to create, even though it doesn't meet the criteria. Obviously, we know better. The point of the shell is to kind of test out our models, our validators, our functions, everything that we're supposed to be doing. That's there for a reason. So it gives you so much power that even though your validators don't work, if you try to use .save, it'll still save it, right? Let's go back to our in here and let's fix these issues. We're gonna say level is equal to 10. Charizard dot description is equal to unknown Pokemon. We can run the full clean method on it to test the validators that we have, and it does not have an error. So I can now just save it to my database. We see here Charizard 100, sorry, Charizard 10, that meets the validator. The unknown Pokemon meets the description validator. Are there any questions in regards to our validators that we used, the full clean method, and how that works? Awesome. Well, we talked about
I think
creating.
Jacob had a question.
Oh, I'm sorry, Jacob. Ask your question. You're muted, Jacob.
I'm sorry. It was just about validators in general. I guess just like it's is the point of validators, like, is it just like they kind of work similar? Do they work similarly as like constraints, I guess? Like, but they're just like built-in functions in Django that kind of make that whole process easier. I guess I'm just trying to differentiate between the two because they seem like they're kind of similar, but I could be wrong.
Yeah, it's essentially a constraint, right? It's a constraint. If we talk in terms of PostgreSQL, if it's checked, right? It's a function that comes with Django, and we are also going to see how we can create our own validators. Because in case we don't have what we need from Django, we have the power to create our own custom validators to test out our fields.
Oh, all right, that
All right,
makes
but
sense.
it
Thank
is
you.
a constraint and it's a form of a check.
I have a quick question too, just to piggyback off Jacob's.
Okay.
So is it like it's kind of like a getter and setter? Is that what I'm tracking? Like for OOP, kind of that concept? Because we have constraints here, but does the validator just essentially tell us like, hey, like I was looking up more about it, it just gives us a validation error, right? If in case like the input to the database doesn't meet the constraints, or whatever you put the validator is constraining.
That's correct. It will essentially it should stop your thing from actually creating your Pokemon instance if you try to create it without meeting the criteria. In the shell, we're able to override that because it's the shell, right? It's still going to give us the power to do it because it's the development area. But thank you for bringing up the question about getters and setters. Let's actually do something like that, like a getter and a setter, right? We talked yesterday about level up. We did change capture status. So let's do that, right? And you are on the right ball track, Sam. We could make like a getter and setter that can check if something meets the criteria. And if so, let's change that field. And if not, then don't change it, right? So let's go back to our model. I'm going to have to exit out of here. And in our model, I'm going to go ahead and change this default so I no longer get that issue when I create a new Pokemon. I'm going to say unknown Pokemon, or I could change my validator. Either or will work. We're going to create the dunder method we had yesterday, which is going to return a formatted string where it says, it gives us back the name of the Pokemon. And we're going to say has been caught if captured, or if is captured. I think was what we did. If self.captured, else has not been caught. All right, that was our dunder method that we created yesterday. We are going to create essentially that getter and setter that you discussed, Sam, which is going to be level up. Right, and then here, we're going to say level for self.level plus equals 1. And as well as doing self.full clean. We're going to run the full clean method. And then we're going to do self.save. And we had another setter, which was change caught status. And it was self.captured is equal to not self.captured. Right? We'll do self. Oh, this one doesn't have self.full clean because we don't have anything here, but we'll just do self.save. All right, because this doesn't have a value there, but we still had this yesterday, so we'll add it in here anyways. Now that I made a change to the description, what do I need to do, guys? I know it sounds redundant. Migrate correctly. Yeah, I know it's not a little redundant. I just want to make sure that we all understand the process of when we manipulate our model, right? So we're going to say Python manage.py, make migrations. Python manage.py, migrate. And I'm going to try out something today, guys, on camera to see if it helps you guys. In case if you guys were working through the assignments yesterday and you found it really annoying to constantly have to import your models, Django does have some extensions that you guys can use. The extension is called Django extensions, right? And what this extension is going to do is allow me to use a specific type of shell that's going to automatically import all my models without me having to manually import them every single time. We do that. It was installed. And to actually use it, we have to come to our installed apps. And you're going to do Django underscore extensions. It should be able to use that now. I have it as a dependency now. So let's go ahead and do a pip freeze into requirements. And this time, when I try to use the shell, instead of doing shell, I'm going to do shell plus. And notice that the shell plus extension is able to import all my models and essentially, my models, my applications, right? We have all the authentication and admin that came with it by default, but it also imported Pokemon app.models. So no, I no longer have to go from Pokemon app models, import Pokemon. That extension does that for me. I just want to take that quick minute or two to show you guys that in case that helps you guys for your assignments. So you're not constantly having to close the shell and open it up and import stuff. Yes, Owen.
With this, you'll still have to migrate though, correct?
Say that again.
With this extension, you're still going to have to migrate your models whenever you change them or add them.
Correct. If you make a change to your model, you still have to migrate. The only thing that this does is, especially once you start having different apps and you have different models, you can, you won't have to import every individual app. It becomes, very useful the more applications you have. But it's not part of the lesson plan, so I don't want to take too much time on it. I just wanted to show that real quick. But I created these methods. I changed my Pokemon field. Let's go ahead. Let's create a new Pokemon. This is going to be Bulbasaur is equal to Pokemon. Name is equal to Bulbasaur. Level is equal to 10. When we run the Bulbasaur.fullClean method, we shouldn't get an error now because the description now meets my validator criteria. So once again, answering James' question, yes, it does matter what your default is if it doesn't meet that validator. Well, let's go ahead and use this level up method. Let's change Bulbasaur's level to 100. Misspelled Bulbasaur.
It's also only going to add 1 to your level, is what I'm understanding. Oh, wait, you're just changing the level manually. Never mind.
Correct. I'm just changing the level manually to see what it does. Right. I'm gonna go ahead and do Bulbasaur dot level up. And we get the validation error, right? It ran the full clean, it raised that validation error. Let's see what the Bulbasaur level says. And it says 101. And if I check my Pokemon, it's not present. Well, the shell is still going to run the command like you guys saw earlier, even though you didn't, even though it didn't pass the validator, as we saw earlier, if we still ran the .save command, it's still going to, change the level. But notice that even though I ran that method, it did not add it to my database, because when it raised that error, it technically the actual command itself didn't really save it. So it's not within my database. Even though the shell shows that the level is 101, the method actually did work. Yes, Owen.
So if you didn't have on line 19 that self.full clean, it still would have updated your database towards level 101, correct? And that line 19 is preventing it from updating your database since it doesn't pass those validators, correct?
Correct. We do that. We changed it. Let's go ahead and exit out. I'm gonna open up my shell plus. I don't have to import anything. Let's create Bulbasaur is equal to Pokemon name Bulbasaur. Level is equal to 10. I should have did 100. My bad. Level equal to 100. Let's do level up. And if we run pSQL and query it, it added a level and even saved it, and notice that it's in my database. So that full clean did stop it. pSQL was a little, sorry, not pSQL. The shell is a little misleading, because if you try to check the level in the shell, it will show you, hey, it's 101. But in reality, it's not 101. The full clean did what it should have done. Right. So if you want to create specific methods that can change your fields, you can use the full clean, just like we were able to use the .save method.
Thank you. That clears things up.
No problem. Does anybody have any questions about the full clean method and how it works, or essentially the setter method that we created here?
Could you go back to your shell?
Of course. I'm gonna say Bulbasaur dot level is equal to 100, and I'm gonna save it so my database doesn't have the wrong items in here. Okay, there we go. But yeah, no questions, guys? All right. Let's go ahead and talk about creating our own validation error. Let me make sure I'm on track with everything. I am. All right. So That's working. The next step is actually creating our own custom validation error. And let's go ahead and exit out of our shell. What we are going to do is go to our project application directory, and we're going to create a new file called validators.py. So within here, the Pokemon app, I'm going to say validators.py. Right, within the app for Pokemon, I'm going to create a new file called validators.py. And we are going to create a new validator, our own custom made. To create our validators, we're going to want to also use our validation error to get the actual error to raise whenever it doesn't meet the criteria. And to do that, we're going to say from Django.core.exceptions. And I'm going to import validation error. And you'll realize how easy it is to actually create a validation error. These imports give us access to the built-in validation error class from Django. And what we also want to do is import RE. Now, the reason for that is because what I'm going to do here is create a validation error that's going to test my name to ensure it meets the criteria that I want. So to do that, I'm going to want to use regex. Now, we are going to go ahead and actually define this. We're going to say define, and we're going to say validate Pokemon name. And I'm going to take in a variable, and the variable is going to be called name. Recall the notes for validators, where in the validators, it takes in a value, right? That value will be whatever we're trying to test against, right? For us, because it's specifically the name that we're trying to test, we're calling it name, right? Now we are going to create a error message with an error message. And the message I wanted to return is going to say improper name format. Next, we are going to create our regex. And this is going to come straight out of the curriculum, so we don't talk too much about regex since it's not a regex example. But the regex is going to be as follows. It's going to be the carrots. We want A through Z for capital letter for our Pokemon, followed by lowercase a through Z. And then we want to be able to take multiple inputs of lowercase letters, and it should end with lowercase letters. So we will use the $sign. All right, this is going to be the regex for us. This means that it's not going to take any special characters and no spaces or digits, right? It should just be a capital letter followed by lowercase letters. I can't even think of a Pokemon with like a space in their name. If you guys can, let me know. Right? So we have our regex, we have our error message. Next, we want to test if our regex works. So we're going to say good name is equal to re.match. We want to match our regex to ensure it can capture the entirety of name. And last but not least, we're going to say if good name, then I want to return name. That means, hey, if there's actually something assigned to the good name, that means that our regex was actually able to capture name. So if good name is actually something, then I want to return it. Else, I want to raise a validation error And notice here that it says the message argument can be a single error, right? So the first argument it takes is a message, and that's where our error message is going to go. The second argument is a dict type. We're going to say params is equal to, we're going to say name and give it name. All right, so it should return an error message saying, hey, improper name format. Well, what's the improper name format? It's going to tell me the actual format of it, and that was assigned to this key name. Now, to actually use it, we're going to go back to our models.py. And before I actually move forward, do I have any questions on creating our own validation error or validator?
What is that params equal name going to do again?
Yeah, so this is part of like error classes or error messages, right? This takes, let's see if we can open it up. It takes one of the variables that it does take is a params variable. And it is a string, right? And then you can put any kind of variable in there. So the string that we added was name, right? And the variable we're adding is the actual name that we are being passed in to check for the validation error. Right? It's to create essentially just our error message. All right, I didn't like make this up. This is just how the validation error is structured. So I'm adhering to its rules. Does that make sense?
I guess my question is it going to show up, like the error message is going to pop up and show, and then
Yes,
is
it's
it
going to show.
also show the name?
Correct. It's going to show the error message, and it's also going to show the params. All right, and we'll see that in play as well right now. So we have that. Let's go back to our models. And then within our models, I'm going to import my new validator. So at the very top, I'm going to say from validators, import my validator Pokemon name. Right, I now have access to that validator that I created. And then within my name field, after the no, I'm going to say validators is equal to, we're going to open and close the brackets like we did on everything else. And we're just going to call our validator that we created, all right? Validate Pokemon name. Do I have any questions about how we created our validator or added it to our model? Notice that we didn't do v dot whatever, right? Because these validators came from the validators module. This is a custom-made validator that we made, so we don't have to use the v prefix. Make sense? I see, Gary, honestly, I was under the impression you guys a regex crash course during the Python week. I guess maybe that changed. We can talk a little bit more if we have time once the lecture is over about the regex and how that came up, if you guys would like. All right, let's go ahead and finish the first part of today's lecture. We're going to go back to our shell, and I'm going to say Python. Oh, before I even do that, I made a change to my model. And just like we discussed before, we have to make migration. Notice here that I altered the field name on Pokemon. So let's go ahead and migrate that change to my database. It is good to go. And now let's open up our shell another time. Shell plus. And I'm going to create a new Pokemon. This is going to be total dial. We'll say Pokemon, the name, and I'm going to purposely mess up this name by saying total dial and adding a number in here. And say level is equal to 15. And now when I run the full clean method, we now see here that I got an error. It says validation error, and it says name and improper name formats. My message. All right, that means that my validator that I created successfully now works. Do I have any questions about validators, how to create them and add it to our models, or how they work? All right, right on. We're gonna go ahead and take a 10-minute break. Time is 10:08. All right, welcome back, everybody. Before we went on break, we talked about validators, creating our custom validator, and then running it against our models with the full clean method to ensure they work. The next part will be our test case, testing out our validators. So as you may have already noticed, when you create your application, there is a test.py file. We're gonna go ahead and navigate to that test.py file. At the very top of your test file, Django, already humbly presents with you the test case. Essentially, the Django.test is it pretty much inherits from the unit test that Python uses. So they're practically the exact same thing. And we want to test out our validators on our models. So obviously to do that, we're probably going to want to go ahead and import that. So the very top of our test case file, we're going to say from Django.core.exceptions. I want to import the validation error. Because it is a test, we should be able to raise validation errors. And I want to import my model. I'm saying from .models import Pokemon, which will give me access to that model within my test case. All right. So to create a test, I'm going to say class. I'm going to call this Pokemon test. Let's try to stick to the naming conventions. I know the curriculum has it differently, but I'm so used to naming like this. Hopefully it doesn't create an issue. I'm gonna say Pokemon test, and then I'm going to inherit from test case. All right. Within here, I'm gonna create my very first test. So I'm gonna say define. I'm gonna call this test 01. Create Pokemon instance. Then taking self. And the first thing I want to do in this test is create a Pokemon, a brand new Pokemon. All right, so I'm gonna say new Pokemon. Call my Pokemon model. I'm gonna say name is equal to, let's say Squirtle. Description is going to be a very bubbly turtle with a spicy personality. All right, whatever you want to add here, it does not matter. All right, but restate Squirtle and description. And what we're trying to do is actually be able to create a Pokemon instance, and then we'll actually test out the validator, right? So once we create the Pokemon instance, we're going to say we should be able to do something like new Pokemon and run the full clean method. And at some point, we also want to see if our test fails, right? Well, we can do this within a try block. We say try, and I'm going to try to test out my Pokemon with the full clean method. And if it doesn't work, it should be because it was a validation error, right? So if the full clean method does not go through, then it would raise the validation error. So the accept should be able to catch that validation error. I'm gonna give it an alias of E, and we can do, let's go ahead and say print. I'm gonna print out the validation error message. So E.message dict. And obviously, if a validation error is raised, then this test should fail. Right. So from top, what did we do? Well, we created an instance of our Pokemon in here that we can use to test against our validator. We created a try and accept block where we can run the full clean method to see if it works. If the full clean method does not raise an error, then this shouldn't run. And what we can also do is check if our Pokemon even exists. So we'll say self.assert is not none. And make sure that there's actually something within my Pokemon. And if the full clean method does not work, as we saw earlier within our shell, it raises a validation error. So because that error is going to be raised, then the accept block should be able to catch it. And if it catches the validation error, that means the Pokemon instance that we created was not valid. Therefore, we should fail this test. Right? Now, let's try to run this test. And I do apologize if I have issues with this test because I struggle with the test module. There we go. So we ran Python manage.py test. This should be somewhat familiar to you guys. You've seen it in the assignments. It looks through your project. We notice that it found one test. It creates a test database, right? So it doesn't actually use our database. It creates like almost an instance of the test database that it can test it against. So if we run our test and it creates a Pokemon, you won't see that reflecting in your actual database because it's not using that database, it's using a test version of that. This dot here signifies that the test was successful and it ran one test, right? Well, that means that our Pokemon validator is working as it should. Or at least our model is as well. Well, let's create a different test. We'll call this test 02. And it'll be create Pokemon with incorrect name format. Right, so we are going to ensure that if for whatever reason someone does create a wrong Pokemon, it's still actually going to catch it with our validator. So this kind of tests our model more than anything, and this is going to test what our validator is actually doing, if it's working as it should. We're going to once again create the Pokemon. Let's copy and paste because I am lazy. But this time, the Squirtle, I'm going to add a 1 in here for the I. And it should not pass because our regex, if you guys recall from the validator, is testing for characters A through Z only and no digits. So this is an incorrect name format. Once again, I'm going to try the full clean method. which is going to run my validators to see if it meets the criteria. We have an except block that's going to catch that validation error. And if it raises that error, we want to make sure that it is the correct error. So we use the assert true test for the check, right? And how do we define our validator? Well, our error message stays in proper name format. So we want to make sure if the validator that we created to test the name is actually the one that's being called. So that's what the assert true is doing. We say improper name format in e.message dict. And what's happening here is when it runs the try block, it's going to run full clean. And obviously it should raise a validation error. The validation error, as we already saw before with the dict and stuff and the parameters that we had set on our validator, right? There is a message that's going to return. That message is improper name formats. So within our test, we are ensuring that the message within that error actually matches the improper name format, therefore letting us know, hey, the validator for the name is what was called. Does anyone have any questions of how test 2 is working?
Yeah, I was just wondering, can you repeat what a message dict is referring to?
Yeah. In our regex, if it fails, well, not the regex, my bad, I misspoke. In our validator, when this validator fails, it's raising a validation error, right? Within this error, we added an error message to return to us as the developer. That message is returning is called improper name formats, right? We define that ourselves, right? So the validation error itself is going to return a message to us. And because of that, we are able to check if the message is within this error. And why are we doing this? Well, because you might have different validators, right? This validator is checking if the name meets the specific criteria for validate Pokemon name, right? But what if we have other validators like, hey, ensure that the Pokemon does not have a number on it. And we have a different validator that ensures that it doesn't have spaces in it, right? Let's say that that work was distributed amongst different validators. This is maybe it's a really bad example, but if we have different validators that do different things, they might return different error messages, right? This is going to check the validators, and the self.assert true is checking that the validation error that was raised was the one specifically for name, right? What if we had a validator that checked, let's say we did something like this where we said, validate Pokemon name has no spaces, right? We had a different validator, validate Pokemon name has no numbers, right? The message that we might get back might be different. It might say something like, name has spaces, right? This one might be name has numbers. So both of these validators might return a different message. This test case might be specifically for one validator. We can say create Pokemon with spaces in name. So if we are testing specifically the validator that is checking for spaces, then we might want to ensure that the error message we are receiving from this one matches what's being given to us. So we would have to change this to like, name has spaces, right? So this checks what specific validator you are, that's being raised to ensure that's the validator we are actually checking. Does that make sense to you, Jacob?
Yeah, I think so. So like when it says ne.messageDict name, it's just saying like that dictionary is what, just like a parameter, and then it just detects that dictionary, and then it like says like this is the name that was input or whatever. Is that what that's doing? Saying like this is the wrong input that was put in as name.
This line
That
of
makes
code
sense.
right here, when you do something like, improper name format and a dictionary, that returns a Boolean, right? Whether true or false.
Okay.
Right. This will return true or false if we did this.
Okay.
The self.assert true is checking if what's being returned here is true. That's what the assert true is.
Okay.
Right. Why do we use assert is not none here? Well, because if we just run the variable new Pokemon and there was nothing in there, this will return none to us. So we use assert is not none. So this will check, hey, is this none or not? If for whatever reason this returns none, then it fails. Does that make sense to you?
Yeah.
Right? Which is why we are using assert true specifically, because in this check here, this will return to us a Boolean whether it's true or false.
Yeah.
Good? Yes, James.
Continuing off of Jacob's question too, what is message dict? Has that been defined somewhere? Is this something, because this is something we're importing, right? So does this live like somewhere in a very random location that Django is or something?
This is coming from the validation error, right? Validation error has specific things in it, right? We have like error dict, error list, message, code. So when it returns a validation error for us, we're able to grab different things that it has in it, right? Because it's a class, so it has different like data members in it. Does that make sense to you? Of where the message dict is doing?
Yeah, so in that line 23 message dict, and then it's pulling from name. So there's a name element or value or key in message dict that we're pulling from for that, or am I not understanding that correctly?
Yes, right here. We assigned it here. Right, we added the name into that dictionary right here on the params line.
Okay.
Right, so we are accessing that dictionary within the message dict. Make sense? E is validation error. We gave it an alias. If I didn't add the alias, this will have to say validation error dot message dict. Or maybe that confused a little bit. We'll keep it at that.
Yeah.
Yes, Gary.
No, I got that part personally, at least. But it's the after the message dict name. Like I didn't understand how message dict was recognizing the name that we input.
Okay, awesome. Gary?
So will message dict?
Hold on. I don't want to cut you off, Byers. Gary did raise his hand, so I have to give it to Gary.
I was gonna say it might be easier to see it like if you right click validation error and you click on go to definition, just so that you can actually see the method. It's right underneath, yeah. Actually, that doesn't.
Message dict is a dictionary that holds a string and a list. Let's see. Are we able to expand this?
So if you right click validation error and you just click the first option.
Validation error.
Yep. It's more readable if you just scroll down a little bit.
Thank you for that.
Yep. And it's right there. So message dict is it's just an attribute of the validation error class.
So it's just got that built.
Yeah.
Gotcha.
Good stuff, guys.
And so we will, yeah, and we will always pass in the parameter for whatever validation that we created. We will pass in that variable name, that parameter.
Yeah, it's good practice. So that way, whenever you're testing it, you can actually be able to do something like this where you can check if it's in there. All right, I'm gonna put a pause here on questions because we still have a second part to this lecture and we are halfway through with our time. All right, so let's go back to our test. Let's run the test again. And we see here, we ran 2 tests. Both of them passed. We have 2 dots here. We got an okay, no errors. My terminal is not yelling at me, so I did something right. All right, so everything so far is good. My validator is working. Now let's go ahead and move forward. So we talked about the making migrations, and so on and so forth. We talk about tests. Why tests? Right? So they help save money and time by identifying errors. A lot of companies use test-driven development where they write the test scores before even writing any code. The code is kind of like made to pass the test. It's not the most efficient, but it is a way of doing it. We tested our model and we even tested our validators. Right? So you guys got an insight of how that's done. Hopefully this gives you a better idea of whenever you are running your tests on your assignments or also in your assessments of what is going wrong and what it's actually testing for to allow you better debugging of your code. All right. Let's go to the next part, which is going to be serializers. And what is serializers? All right. So I don't like this example too much, but Django serializing framework provides a mechanism for translating your Django models into other formats, right? And you saw the type of data we were getting, but serializers allows us to kind of convert it into a form of JSON, which is going to be very important once we start working with our front end. Let's open up these slides. Do we not have slides, please? Okay. Right. So the serializers allows us so we can handle specific requests from our front end, and we can move data across from the back end to the front end in a format that it understands. Right. We're going to learn how to create our serializers and actually use them. Let me get set up here. So I am within my test. Let's go to our Python shell. Let me exit out real quick. We are going to go back in here, Python manage.py, shell plus. Just in case I made any changes or whatever. Now, what we are going to do is we are going to create a Pokemon. We'll do Blastoise is equal to Pokemon. Name is Blastoise. And the level is going to equal to 25. Blastoise.full clean. It's working. I can print out Blastoise, see the Thunder method. Blastoise has not been caught. All right, because the default is set to false. So for the serializers, there is a specific import that we want to use. And I don't believe it got imported in here because we have yet to add it to any of our models. So we're going to have to import this manually. And the import, we're going to do it within the shell first before we actually do it in our code. We're going to say from Django.core.serializers. I want to import serialize. Right. So to serialize a Pokemon, what we are going to do is create a new variable. We'll call this Blastoise SER for serialized. So I'll spell it out. We are going to call the serialize module that we imported. I want to convert it into JSON, and I'm going to pass in a parameter. Let's do Blastoise, just Blastoise. And notice that I get an error, right? The error is saying that Pokemon object is not iterable, because the way that serializing works, it expects a list of objects, not just one object. So whenever you guys go through your serialization, make sure you guys add a list around your objects. And we run that, and we now do not get an error. And we can say Blastoise, SER, and we get our Blastoise in a serialized version. But what do you notice about what returned from Blastoise serialized?
Like just talking about the dunder method, like just all the information.
The information that returned to us, what is this?
An object.
Is it?
Or no, it's a list. It's a list of
Diction.
So list of
Close.
dictionaries.
It's actually of type string, right? If I try to do something like Blastoise, SER, and I did, 0 for the first item in here, because obviously it's a list, right? And I did like dot get, and I wanted to grab the primary key. We're gonna get an issue here where it says string object has no attribute get. All right, so it doesn't give it to us exactly how we expected us. We're given an error due to the fact that the serialize method takes in a list of objects and it returns to us a string of of a dictionary, kind of, if that makes sense. Right? Now, to actually grab that data, what we are going to do is import a JSON library. So we're going to say imports JSON. And this should look a little familiar, I believe. And we can say JSON Blastoise. And we're using JSON.load. I believe you guys did this with files. Does the dot loads look something familiar? Gary says, I remember briefly. Awesome. We're importing JSON to take advantage of the JSON.loads method. And we are going to add our Blastoise serial method that we created here. And let's call JSON Blastoise. And there is no longer a string around our JSON object, right? Or our serialized object that we had. All right, so the serialization converts it into a string format that we can now convert into JSON, right? So it's kind of like a middleman to be able to convert it to a different type of format. And then we use the JSON.load to take that string to actually convert it into a JSON object. And now if I do JSON Blastoise at index 0.get primary key. Oh, my bad. Press enter by accident. That did not print out what I thought it was going to print out. Let's do primary key. Okay. PK is equal to JSON Blastoise 0. Sorry, the shell is being nitpicky. Print out PK. Oh, I'm
Would
getting
you need a
nothing.
dot
I apologize.
notation?
I'm getting none, right? It's not that it's being picky, but it's giving me none because there's none saved in here. What did we do? Instead of PK, we do fields. Dot get fields. There we go. Now we're getting something. My apologies. It didn't have anything saved in the PK, and I think the reason for that is because we didn't save Blastoise. So as a matter of fact, if I do Blastoise.save, let me print out Blastoise. Okay, it's an object. Let's do Blastoise underscore serial is equal to serial lies. I want to serialize it to JSON. Let's add the Blastoise in here. Print out Blastoise serial. It's a string. Cool. Let's do JSON Blastoise is equal to JSON.load. And if I print out JSON Blastoise, it is a JSON object now. We should be able to do get PK. And this requires an index because it's a list of objects. Now it has a primary key, right? So the reason it was not giving me anything when I was trying to get PK is because Blastoise wasn't an actual like saved object within my database, right? The .get objects.all that stuff is essentially querying my database, but because it was never added to my database, it never gave it a primary key. Therefore, PK was set to none. So when I did get PK, I wasn't getting anything back. But it did give me my fields. So I recreated Blastoise. I saved them. I serialized them into that little string format of what looked like JSON, but was actually a string of it. I used JSON.loads to convert that string into my JSON object. And now I can actually grab stuff in there because it's an actual working object. Do I have any questions on how serialized work, how we serialize it, or how we convert it into JSON? Yes, Owen.
I imagine you're doing this on the shell just to display what it's doing. Are we going to go into like how to actually? Okay, thank you.
Yes, absolutely. Right. So now that we saw it in the shell, let's actually use this in our code. Right. Well, the serialize doesn't come specifically from Django. It comes from one of, I would say it's like a feature of Django. It's called Django REST framework. Right. So we have to import that dependency. Let's go ahead and exit out my shell. Ready to come back to the terminal where my manage.py is located at, and I'm going to say pip install Django REST framework. Right, serialize is not something that comes by default with Django. It comes from the Django REST framework. We run this, and we see that it installs it. What do we need to do now that we installed a new dependency, guys?
Pip freeze.
Pip freeze into my requirements.txt. Let's go ahead and double check it in there. Django REST framework was successfully added. We are good to go. And now it is a form of an app. And for Django to speak with Django REST framework, we need to go to our settings and actually add it into our installed apps. So within our installed apps, you're going to open and close quotation marks, and it's not going to be added within the apps as Django REST framework. It's going to be as REST underscore framework. I know it's a little confusing, but that's how it takes it in. within the installed apps. Why wouldn't it be called the same? I don't know. I didn't create this. Let's look at Django REST framework. This is the Django REST framework documentation. There's no search here. Let's go to development. No topics.
The search is on your
Oh,
right.
there is a
the
search.
button.
Thank you. Serializer fields. So the serializer fields are declared in fields.py. You want to import it from the REST framework, import serializers to refer to the fields as serializers. So we're gonna have to import the serializers. And essentially what it does, and it's gonna become very useful for us, especially in our classes, is it takes a model and it'll serialize all the different fields for you within that model. This wasn't exactly what I was looking for. Django REST framework. Serialization. I'm trying to show you. I guess maybe it'll be easier if I do it and show you along the way. All right, let's actually try do it and show you how it works so we don't waste time. So we installed the Django REST framework, which will now give us access to the serialization of it. And to do that, what we are going to do is go and create a serializers.py file. So within my app, I'm going to create that new file very similar to how we did the validators, but now it's going to be for our actual serializers. So let's create serializers.py within our Pokemon app. It's going to be new file. And we're going to call it serializers.py. Now that we have a specific document for the serializers, we're going to go ahead and import the serializers. So we're going to say from REST framework, I want to import serializers. Well, what do I want to create a serializer for? Well, it's going to be for my Pokemon model. So I'm going to say from .models import Pokemon. Now, we're going to create a Pokemon serializer. So we're going to create a class, call it Pokemon Serializer. And we are going to inherit from the serializers class. So it'll be serializer.model serializer. And I seem to get an S here. All right, so the S. Notice the capitalized M and S. Make sure that's correct, or you're going to get an issue. I say that because I've done it. We are going to create a class within this class. It's going to be called meta. All right. And this meta class is going to take in two data members. One is going to be the model that we want to use, which is going to be called Pokemon. And I want it to return to me specific fields. So we're going to create a fields variable here. And there's two ways to add in the fields that we want to return. One can be specifying every individual field that we want within our brackets here. And it would look something like this, where we'd say ID. We can say name. And we can say level. Or we're going to say all. So one or the other will work. The all will grab every single item within our model, or we can use specific fields that we want to return. For this demonstration, we're going to do ID, name, and level only. Right? So what happens when we run the... I'm sorry?
The dunder all has to be in quotations?
Yes, James, it does have to be in quotations. Good question. So if you guys decide to use a dunder all, it has to be in quotation marks. Right? For this specific serializer, I'm only going to want to return 3 fields. When I run the Pokemon serializer, it's going to run the meta class, add the model that I want to use, and the fields that I want to serialize. All right, welcome back. We're going to go ahead and continue on from where we left off with the Pokemon serializer. I took a request from Owen in regards to maybe drawing out the serializers in a way that we can visually see and understand. I put the first part of the drawing on Slack, but I added some kind of extra additions to it, and I want to talk through it real quick. So your serializer, the down and dirty best way of explaining it is essentially serializing is by unpackaging or packaging data, right? Which one you are doing depends where the data is going or coming from, right? If we have data coming from the front end to our back end, we consider that as unpackaging data. And if it's going from the back end to the front end, we want to package it. Right here on this nice little drawing, we have our front and our back end. Notice that the data on the back end is what you would see as your query sets or your models. And then the data from the front end is your JSON objects, right? If we were going in regards to the scenario of unpackaging data from the front end, the way that it would work is the the user will put in some form of a request. Let's say he wants to add a Pokemon to his Pokédex, and they will put in that request, and essentially we will want to grab the query from our backend in the form. Oh, let me go ahead and take a step back. Let's actually do this. Let's bring up my notes for this and see if we can kind of understand it. Right, so serializing it. The scenario is if a user wants to see a list of Pokemon, he would put in a GET request that looks something similar to this. And you guys have already been doing something very similar to it whenever putting in GET requests to different APIs, right? The scenario here is that we have the Pokédex.com application. It's going into our API. It's requesting from Pokemon, and the specific Pokemon it's asking for is Pikachu, right? So we essentially take in the request from the user, and we are going to grab that Pikachu from our database, right? And we've already seen how we grab that from our database by using the Pokemon.objects.get method. We take in the request from the user, which is Pikachu, and use that to add it into our query, which is where the name equals Pikachu is coming from. We run that query and we save it to a variable called requested Pokemon, right? That is the Pokemon the user asked from us. Now, this is going to return the data from our database, which essentially looks pretty much to this, right? We see the Pokemon ID, name, and level. We kind of saw that in our shell as well. And you guys should already know up to this point that the front end doesn't work this way, right? It uses JSON usually especially with React. So we need to find a way to convert this into a data format that our front end can use, right? So we need to serialize our data into a JSON format. And that's where the Pokemon serializer comes into play, right? We create a variable called serialize Pikachu. We call the Pokemon serializer. We pass in the Pokemon that we want to give to our user that he had requested, right? We queried it, saved it to the variable called requested Pokemon, pass it into our Pokemon serializer, and it will save it into this variable. And essentially what will happen is it will convert what used to look like this from our database into a JSON object, right? Where we have the ID, name, and level. That way our front end can read it, right? I did put a note here that sometimes we might have to query multiple different objects, right? And we see that if in case the scenario was that the user wanted to get all the Pokemon available to him, the way that our backend would handle that would be something like this, where it's Pokemon.objects.all to grab all the Pokemon. If you wanted a specific type of Pokemon, there is other query parameters that we can use that you can find in documentation, which I believe we went over very briefly, where it was filter, right? And we can filter everything where it says like Pokemon types, if we had a field for it, is equal to like fire, right? And essentially, if our Pokemon had a field type which was Pokemon type, we would go to our database, look for every Pokemon type we had that was fire, and we can pass that within our serializer, right? And then we will give it the argument of many equals true to let it know that we are passing in a query set, and it will serialize for Pokemon. And instead of having just one individual item within this object, it would have a variety of them, right? So that's how the Pokemon would work. The Pokemon serializer would work if we are deciding to send items out, right? This is the serialization portion. Once again, referring back to our diagram, we are grabbing the query set from our database. We are serializing it into a JSON data format so our front end can receive it. It starts like this and ends up like this. That is the first scenario. The second scenario would be deserializing, right? So a user wants to add a new Pokemon into his Pokédex, right? He puts in a post request, and we have yet to get into it, so I'm not going to get too deep into the weeds about what post, put requests, and get requests are. But essentially, a post request is creating something into our database. Where a get request was grabbing stuff from it, the post will create something, right? We will talk about URLs tomorrow when we start making them, but essentially the URL that for a post request will look something very similar to this, where we will essentially put in a post request to these URL points, which will lead us to the Pokemon. And then the request itself has a field called data, right? That the front end will manipulate, right? It would add in what type of Pokemon we want to create into this request.data field. It'll be in a JSON format. Once our front end grabs that data that the user wants to use to create a Pokemon, it's going to go ahead and send it to our backend, right? So it comes in a JSON format, and it's going to get to our serializer. And what our serializer is going to do is convert it into a data format that our backend can understand, right? So our backend does not understand how to read this data format, so we need to deserialize it or unpackage it into a format that our backend understands. So we essentially call our Pokemon serializer method. We grab the data from the request from the user and assign it to a variable called data that our Pokemon serializer model is tracking. That comes built in with the serializer model. So we didn't create this. It came when we inherit from model serializer, right? So we put in data is equal to the data that is coming from the request, right? The Pokemon serializer is going to go ahead and serialize this. And that's where the is valid comes into play. It's going to take this JSON object. It's going to see, hey, does this pass the validators that your model currently has set up? And does it have like, all the fields that it needs? And if so, it's going to allow us to save it. If it doesn't, this will return false, right? We kind of saw that already in play, where it returns false, or it's going to return true whether it passes it or not. If it returns true, then we save. And then the serialized Pokemon is now added to our database. Once it passes through this part, it'll look something very similar to this. Right? So deserializing and serializing, it's going to depend on how you use it, whether data is coming in or data is going out. The serializer is essentially an interpreter where it interprets what type of data it's using and converts it to something that we can understand depending on what part of the application we are in. So returning back to our Pokemon serializer, we created our serializer that's going to use our model Pokemon, and it's going to serialize the ID, the name, and the level. So let's go ahead and go into our shell. And we'll run shell plus. And one thing that it does not do for me is import my serializers. So I'm going to say from Pokemon app.serializers import Pokemon serializer. And we are doing it in our shells to see how the serializer works. Well, let's start with the first scenario, serializing data, right? Let's say that the user, right, wants to see a specific Pokemon. Let's say the Pokemon is Pikachu. So what's going to happen in our application is that we're going to take in that request, right? We grab the request, we see the values that are in that request, which is Pikachu. And we say requested Pokemon is equal to Pokemon.objects.get. And I'm going to grab that specific Pokemon that the user requested from me by using name. And then here is where I would add like the variable, right? That's coming from the URL. But because I'm using the shell, I have to explicitly tell it what I'm looking for. So I'm going to say Pikachu. Right, we have the requested Pokemon. Notice that it's given it to us in a query set. This is the backend talking, hey, I got the request from the user, but the data format is currently right now in what Django understands. But obviously, if I want to give it to the user, I have to serialize it, right? So we say serialized Pokemon is equal to, and then we're going to bring in our serializer into the equation, and we pass in the requested Pokemon that the user wants. And this time, when we print out this Pokemon, it is essentially a JSON, but we can't really see it from here. We have to use a command called .data. So we use .data, and it shows us the actual JSON object that belongs to that serialized data format, right? So now it is in a JSON format, and then we send it to our front end. Do I have any questions in regards to serializing our object and send it to the front end? Yes, Owen.
Yeah. Did I miss, or are we going to go over later, like how to actually implement what you just did in the shell into the code?
That'll be tomorrow's lesson, right? I'm just giving
yeah,
you the
you already
scenario
told me
here.
that. I apologize.
It's okay, right? So this scenario was, it only requested one Pokemon, but as we mentioned, we can also do multiple Pokemon, right? So let's say the request that we got from the user was to grab all the Pokemon. So we can say all Pokemon is equal to Pokemon.objects.all. When we query it, right, it's in a query set data format. It is not JSON, so we need to serialize it to send it out. So we say serialized all Pokemon. I'm going to call my Pokemon serializer. And I'm going to say Pokemon. And as we mentioned before, for a query set, we need many equals true, right? Before we didn't need many equals true because there was only one query, but this time it is a set, right? It says all Pokemon is not defined. That's because I misspelled it. I apologize. Go ahead and change the spelling. Run the serialization again. And now when we look at the all Pokemon, once again, it's trying to give us the JSON data, but we need to specify that I want the data from it. So I use dot data, and then now it gives me the JSON data format of what used to be my query set. Yes, James.
Just a quick question. So I know how we make our own serializer class up there and we identify the fields as ID, name, and level. Is that what the user slash customer is going to have to just accept from us because that's how we built the serializer to give it to them like that? Or would this change based on maybe, I guess, the product manager saying, hey, no, this is how we're going to give it to our customers?
Yeah, so that's obviously going to depend on what you want to do for your application. Should the user be able to grab all the information from Pokemon, then yes, ideally we do want to do all these fields. So I would change that. I did this for like a demonstration purposes,
Gotcha.
but yeah, we can send them all the fields. Depends how much data you want to give the user.
Okay, gotcha.
Yeah, no problem.
Thank you. Thank you.
So we
Great
saw
job on
how.
explaining this, by the way.
Thank you. I was like trying I was honestly busting my head like how can I explain to the guys where it makes sense. So that's the first scenario, right? We got the request from the user that it wanted a specific Pokemon. So we got the query set, we serialized it, right? And we gave it back to the user in a JSON format, right? So as you can see, the serializer works both ways. It can take in JSON data and it can take in query set. Well, we just showed how to serialize it to send it out. Well, let's show again how we can do it to serialize to take it in. And we're going to use a example where we'll create a Pokemon. Let's say I'm running out of Pokemon names. We'll call it Mew. It's equal to, and this is supposed to be a JSON object. So name is equal to Mew. And level is going to be 40. Right? We print out Mew, we see here. This is in the scenario where the user wants to create a Pokemon, right? They put in a push request like, hey, this is what I want. I want to create a Pokemon called Mew, right? And it's this level. Here is the JSON data for it, right? That is the first scenario, which is serialization. We saw deserialization earlier. Now we're looking at serialization, right? It put in that get request. Oh, I'm sorry. Let me take a backtrack. Earlier, we saw serialization, right? We saw serialization where it wanted a Pokemon, so we gave it that Pokemon, and we got the query set converted into JSON. But now the front end, it wants to create something new in our database, so we have to deserialize that information. It is sending a request. Within that request, we have data, which is in JSON format, ID, name, and level. That's what we're seeing here. We have this JSON format data where it's Mew, a specific level, all right? It's giving that to us, to our backend as a JSON format. Well, we need to be able to convert it into a actual object of our Pokemon. So we say serialized Mew is equal to Pokemon serializer. And because this is a JSON object, we have to say data is equal to Mew. And this is where the if valid comes into play. We just took in JSON data. We have to make sure that the data we got actually matches our validators and our fields, and it's within the criteria that we set our model to be. So we have to say serialize mu dot is valid. And it comes back as true. And now we can save it into our database. Right? So we come to our pre-SQL, we can select our Pokemon app, and we now have Mew. So our serializer works both ways. It can take on JSON data and convert it into our queries or query sets or models, or it can take on query sets, queries, models, and convert it into JSON, right? Whether the information is coming in or the information is going out, that's what makes something deserialization or serialization. If it's going out, we are packaging it up and we are serializing it. If it's coming in, we are unpackaging that data and deserializing it. Does anyone have any questions at all about serializers?
This clears it up so well. Thank you.
Okay.
That was good.
Yeah, no, I'm sorry. It was 99% my fault. And I just want to make sure I can deliver this information to you guys in the best way possible. I can add this updated serializer into our Slack, and I'm also going to add the notes for the serializer review if you guys want to see the examples of how that would work as well, right? But once again, the serializer is that way we can change data format from our front end to our back end or our back end to our front end so they can talk amongst each other, right? Because once we start creating our endpoints and we start creating like get requests, post requests, we need a way that our back end and our front end can talk to each other and exchange data effectively, right? That's what our serializers are doing for us. Before I stop the recording, do I have any questions?
No, that was good. Make sure y'all add that to the lecture, to the curriculum.
Of course. All right, I'm gonna go ahead and stop the recording.